So what we're working on today is graphing a quadratic in standard form. Now, this is typically done because quadratics are going to come in this simplified format. We're not going to see them in factored form or vertex form too terribly often. So we need to know how to work with this, and there's a couple different ways. You can either A, learn a couple different formula on where we find the vertex and how we find the roots and things like that. I like to see, can we factor this equation? Because we're going to learn about something called the quadratic equation later on, but most of these are going to be easily hand factored. So we're going to pull out an old trick that we have where we're going to factor this into the two roots. Our first trick is we take the first and the last numbers and we multiply them together. So I have a 1 times a 3, which is going to give me a 3. And because that's a positive 3, I know I'm going to be finding the sum. And then what I do is I take a list of all possible factors of 3, which the only one I have is 1 times 3. And I'm going to see which set of factors add up to a 4. And like I said, conveniently speaking, this one does add up to 4. So I'm going to be able to rewrite this expression as an x squared minus 1x minus 3x plus 3. What I've done is I've split the 4 into two terms. And what this allows me to do is this allows me to move forward and pull out my GCFs. Pull out GCF of x and of negative 3. Anytime I have a negative leading coefficient, I'm going to pull it out with it, which means that if I pull out an x and a negative 3, so I have x squared divided by x, negative 1x divided by x, negative 3x divided by x, so that's x, and then minus 1. And what we notice is that both terms, now that I've pulled out the GCF, both share an x minus 1. So I'm going to factor that out. X minus 1 times x minus 3. And this is really what I'm after, is this piece right here. Because as we've seen previously, these two factors allow us to graph our quadratic. I know that I'm going to have a point at 1, and I know I'm going to have a point at 3. If you don't remember how that happened, well, we took two roots. We said root 1 was when x minus 1 was equal to 0, which we add 1 to both sides. There's our first root. And for our second root, we know that we took x minus 3 and set that equal to 0. Add 3 to both sides, and I get my other root. So root 1, root 2. The second thing that we went over was we said, hey, if I found my two roots, my vertex, that maximum or minimum point, is going to be directly between them. And I know that's going to happen somewhere at x equals 2. I don't know how high, I don't know how low. The only way to actually find that out is to take my x equals 2 and plug it in. So I'm going to plug in f of 2 equals squared minus 4. I'm going to plug a 2 wherever I see an x. And then I'm just going to go ahead and solve it. So 4 minus 8 plus 3. 4 minus 8 is going to be negative 4 plus 3 is going to be negative 1. And that's actually where my vertex is at 2, negative 1. And that allows me to graph that right there. Now the cool thing is I could have plugged it into this as well. If I plugged in a 2, that would be 2 minus 1. 2 minus 3 would be negative 1. So 1 times negative 1 is still going to get me the same answer. So plug it into whichever one you think is easier to do. So let's try that again. For question 3, we're going to do the same thing. I'm going to take that first number and that last number, and I'm going to multiply them together. Negative 1 times negative 8 gives me a positive 8, which means I'm finding the sum of these factors. Now, this set of factors is a little larger. 1 times 8 equals 8. 2 times 4 also equals 8. 3 doesn't work, 4 doesn't work, and so we've done what I've called completing the loop. I'm going to add them up. 1 and 8 make 9, 2 and 4 make 6. I'm looking for a set that makes 6 right there. So I'm going to split my 6 into a 2 and a 4. And we know this is because that will allow me to recombine later on and get a negative 6. And then, let's stay consistent, I'll keep with purple. To factor these things, again, if I have a negative leading coefficient, whatever I pull out is going to be negative. I have an x here and a 4 here, which means that if I have a negative x and a negative 4, it's going to change both those signs and give me an x plus 2. This is going to change both those signs and give me an x plus 2. And because those are the same, I'm going to pull out an x plus 2 and get that. And again, like we've said, this is what we're after, is we want to get an equation to where we can very easily look at what's going on. Well, if I were to solve for that, I would get a negative 2. Let's see, add the 4, that'd be a negative 4. Again, if you actually want to see it written out, root 1, root 2, x plus 2 is 0, subtract the 2, boom. Negative x minus 4 is 0. Negative x is 4, x is negative 4. Boom, there we go. And so this time, I'm going to take that middle value, and instead of plugging in the original one, I'm going to plug it into my new equation. And I'm going to say, okay, f of, let's see, this is negative 1, negative 2, negative 3. I'm going to plug it into right here. So negative 3, negative 3. Negative 3 plus 2 is negative 1. Negative makes it a positive 3. Minus 4 is negative 1. So my f of negative 3 is positive 1. Tells me my vertex is right here. So my quadratic is going to curve just like that. Perfect. And so with this one's a little trickier. So take a second and think, how am I going to split that? How am I going to graph that and find the two roots? Well, there's no b term by the looks of it. And what we'll actually realize is there is a b term. Even though I don't see that middle x, it exists. It's just got a coefficient of 0. Because 0 times anything is 0, and I would skip writing that if I were the problem. So that tells me I'm looking for whatever 1 times negative 4 is, which is a negative 4. In this case, I'm finding the difference. I want to find a difference of 0. So 1 times 4 is 4, and 2 times 2 is 4. Well, the difference between 1 and 4 is 3, and the difference here is 0. So I'm actually going to be using the 2 and the 2. And because I'm taking the difference, they have different signs. So x squared plus 2x minus 2x. And we see that these would actually cancel out, and this would simplify down to our original question. Pull out my GCFs, the leading negative. This is going to give me an x plus 2, x plus 2, which means I can pull out that x plus 2. Get an x minus 2 left over. And this is what we're after. That's going to tell me that I have a root at negative 2 and a root at positive 2. I know that my vertex is going to be somewhere here in the middle. And that middle is going to be x equals 0, so I'm going to plug that into my equation. And because it's 0, I'm going to plug it into the original one again, because I know that that's going to be much easier for us to handle. Yep. Because if I plug in a 0 squared, it's literally just my last term, my constant. Perfect. So that will give me the ability to graph just like that. There we go. Let's try something a little more advanced. So what happens if we have, with these new problems, something where I don't have a c? Originally I didn't have that middle term, I didn't have my b, but now I don't have that constant that's just on the right. Well, these are actually going to be a little easier to work because immediately I notice that somebody has distributed an x. So I can divide out an x out of the expression, which is going to give me the thing that I seek without having to factor it any further. I just boop, boop, there we go. I have my two roots. So root 1 is where x is equal to 0, and root 2 is where x minus 4 is equal to 0, which means that x must be equal to 4. So I have those two values to plug in, which is going to look like this and this. Perfect. And if I know I have two values at 0 and at 4, I know that my axis of symmetry, or that line where my vertex is going to be right in the middle where x is equal to 2. And so all I need to do is plug in f of, I can either plug 2 into this factored form or in the top form. I'm going to plug it into the top one myself. So plug in a 2. Let's see what we get. Well, 2 squared is 4 minus 8. That is negative 4. Draw my negative sign a little bigger right there. So boom, I have a vertex right there. So I know that my graph, curve, curve, and curve. So I have f of x is equal to x squared minus 4x. Perfect. Looks like that. And as we move forward, really just what we're getting into is some other variations of it. If you have something with an actual coefficient, the process is no different. You're just going to have a larger set of numbers that you're pulling from. Also, with that larger coefficient, what we'll learn later on is that means the graph is going to be much skinnier because the graph is going to be stretched. But we'll see that from our resulting graph. So we're going to work it out with 4 times 15, which is 15. And actually, I think this is a good idea. I'm going to pause it right there. Why don't you try the next 2 questions and unpause the video when you're done to see how you do. I think this is a good chance to try those out. Okay, so now we're going to go ahead and resume. Kind of already led you along here where I said, okay, we're multiplying the first and the last numbers, which is going to give us, okay, well, I kind of asked you to pause there on an interesting note because 4 times 15 is not 15, it is 60. So a lot of you are probably shaking your heads, saying things to the screen because, yeah, you were trying to get 15 to work, which would make 16, and your graph's going to be completely different. Well, so that's actually going to be 4 times 15 is going to be 60. So what I want you to do is I want you to take a pause in this video, and I want you to take factors of 60 and see if you can't finish this out and try the next one as well. I think this is a good chance to try out our skills. Okay, so now that you've unpaused the video, let's see how you did. Well, my factors of 60 this time are quite lengthy. I got 1 and 60, 2 and 30, 3 and 20, I have 4 and 15, 5 and 12, 6 and 10. 7 doesn't work, 8 doesn't work, 9 doesn't work, 10 has completed the loop. So I know with that plus 60, I'm going to be looking at sums. So 61, 32, 23, 19, 17, and 16. Ooh, that means the last ones is what I actually needed. So I'm going to go ahead and I'm going to plug those in. I'm actually going to draw this down here so it gives me a little bit more room. So 4x squared plus 6x plus 10x plus 15. And that's going to allow me to pull out 2 GCFs. Over here it looks like a 2x. Over here it looks like a 5. So 2x plus 5. Once I divide those things out, that's going to give me a 2x plus 3, 2x plus 3, perfect, 2x plus 3. And then my other factor is going to be 2x plus 5. Awesome. And so that means that my 2 roots are going to be, I'm actually going to do that up here, root 1, is going to be where 2x plus 3 is equal to 0, and my root 2 is going to be where 2x plus 5 is equal to 0. Separate that off a little bit. So if I subtract my 3 and divide by 2, that's going to give me an x equals subtracted 3 divided by 2. If I subtract my 5 and divide by 2, I get those. So my 2 roots. Negative 3 halves, which is about 1.5, and negative 5 halves, which is right there. Awesome. And so the next thing I'm going to do is I'm going to have to find where the vertex is. And luckily for us, directly between negative 3 and negative 5 halves is going to be negative 4 halves, also known as negative 2. So let's go ahead and plug that negative 2 into our function, either up here or down here. And so I'm going to plug it into the factored form, just because I want to be different. I want to show different things. So f of equals, that's a 2, and then I open my parentheses, plus 3, 2, plus 5. I'm going to plug in my negative 2. Can't really tell that right there. That's a 2 times negative 2. It's going to give me a negative 4 plus 3, negative 4 plus 5. Negative 1 times positive 1, which is negative 1. So negative 2, negative 1. Perfect. And so we notice that, again, we mentioned earlier that that 4 is going to be stretching it. This is a much tighter graph. It's not that nice spread out graph that we have right there. This is very tightly bound. So we're going to play some more around with that in a later lesson. And then the last one, this is another one of those where I'm missing that middle term. So I'm going to be looking for factors of 4 and negative 9, which is a negative 36, which in this case make a difference because of that negative sign. Means I'm going to be subtracting the 2 numbers instead of like we did up here where we added them. So I have 1 and 36, 2 and 18, 3 and 12, 4 and 9, 5 doesn't work, 6 and 6, and that completes the loop. So if I need a difference of 0, I need the same number, so I'm not going to worry about those. I know it's going to be my 6's. So if I have a 4x squared plus 6x minus 6x minus 9, that's a good place to start. So 2x, because I have a leading negative, 3. So 2x and negative 3. And if I divide those by 2, I get a 2x plus 3. Over here, if I change the sign, that also becomes a 2x, and that now changes to a plus 3. Hey, perfect. So I have a 2x plus 3 as one factor, and for my other factor, I have a 2x minus 3. That's cool. So I have the same thing. This is what we're going to call a conjugate. So we'll We'll see more about conjugates later on. And so my two roots, root 1 is where 2x plus 3 is equal to 0, and root 2 is where 2x minus 3 is equal to 0. So let's see. If I subtract 3 and divide by 2, there's 1. If I add the 3 and divide by 2, there's the other one. So I have negative 3 halves, and I have positive 3 halves. So negative 1.5 and positive 1.5. Awesome. And those look like, to me, I don't know about to you, but those look like they're on opposite sides of my y-axis. So I know that vertex is going to be somewhere where x is going to be equal to 0. So I'm going to plug 0 in up here because this looks like it might be a little more work. Not much, but a little. 4 times squared minus 9. And if I plug in that 0, well, that made that easy work. F of 0 is negative 9, which unfortunately on my 1-by-1 graph, I'm going to have to change things up a little bit. I've already graphed my x's, so my x is going to stay by 1s, but in order to fit my y on there, I'm going to have to make my y by 2s. So now it's 2, 4, 6, 8, 9. There we go. Perfect. And there we go.